Hello programmers, and welcome to a video about functions. Functions, that's the word right there. So today we're going to be covering the question, what are functions? We actually know the answer to this already, but we'll review it. And then we'll look at how functions get used, and most importantly, the real point of this video is to get to the idea of defining our own functions and using them to improve our programs. So without further ado, let's go into the programming world. Unlike in previous videos, I have just gone ahead and started a new little experiment project I've called Functions Experiments with the template, and put that into my Cart253 repository in the experiments folder. You can see here at the top of my window that's what I've done, just to save a bit of time. We probably don't want to watch me doing that every single time I start a video or a sequence of videos. Okay, so let me just throw together a little bit of stuff. So we have been seeing functions throughout our programming journey, because we're constantly using them, right? That's the biggest one. So for example, I just wrote create canvas almost without thinking, and this is an example of calling a function. So a function is a collection of code that does something amazing, or just at least useful, and that has a special name. So this one is called create canvas. That's why I write that first. And it may be we have to give it some information to do its job. That's what we put inside the parentheses. We know that these are called arguments. And it goes off and it does whatever job it's supposed to do. Most importantly, we don't actually need to know how it does that job, right? We don't know how create canvas creates a canvas in our browser window and gets it all ready and sets it to the right dimensions and everything. And we don't need to know, and we probably don't want to know, because that would just be more detail than we need. So one of the big things that is great about functions that other people wrote, like this P5 function, create canvas, is just this power to get something done without needing to know the details of how to achieve it. And this is true of all of these nice functions that we get in P5, like setting the background to black. We don't need to know how the background function does that. We just need to know how to use the background function, and then we can rest easy knowing that P5 will go away and do whatever it is that needs to be done. Same thing if I draw an ellipse on the screen, right? In the center of the screen, and my usual ellipse, 100 by 100. I don't need to know how the ellipse function goes away and draws an ellipse with those arguments. I just need to know that it will do it, and I need to know how to tell it to go and do that. So functions are amazing, and so far, a lot of what we've been doing is calling these functions and learning how to call these functions, speaking the language of those functions. And in this instance, the vast majority, perhaps all of the functions that we've been using are things provided by P5. So let me just run this so that I've got a working version of this program. It's my usual starting point, the diskette, or the circle in the center of the canvas experience, pretty traditional. Okay, so we're calling three functions in here. We're calling create canvas to make a canvas, we're calling background to set the background to black, and we're calling the ellipse function to draw us a circle with these arguments or properties, if you like, that I'm telling it to do there. So we already understand that functions are super duper useful. The flip side of calling a function is this idea of defining functions. How does a function actually know what the steps are to accomplish something? So somehow background knows, a set of steps. We know that the background function must have more programming inside of it that we can't see, a series of JavaScript instructions that tell it what to do to draw the background. So how do we go about defining what a function is meant to do? Well, that's something that we've been seeing as well, thanks to how P5 works. So that, for example, we see here, we are defining the setup function, right? The setup function knows how to do a specific thing. It gets called in order to accomplish the task of setting up our program. But we don't call it. We know that P5 calls it. Instead, what we do is we define it. We say what those steps are. And in this instance, I'm saying that there's only one step to setting up, which is to create a canvas that's 500 by 500 pixels. So let's take a look at this function definition here. The function definition is the thing that tells the function what it does, and that makes that function exist. It's like a variable declaration in that sense, right? By defining the function setup, I'm basically making the function exist in the program. So a function definition, you can kind of see the pieces, of course, because we're looking at them. The first thing we always write is the word function. It's a special word in JavaScript that announces that we're going to define a function. You can see it gets highlighted in purple because it's a special thing. So that's the first thing we write. The very next thing we write is the name of the function. So the name of the function here is setup. That's, as we know, it's a special name within P5. So by defining the setup function, which corresponds to something that P5 knows about and will call for us, we're kind of hooking our function into the way that P5 works. So this is a function that we're defining that P5 knows about and will call for us. So that's the name, setup. You can see it's highlighted in blue for me because it's the name of a function. After the name of the function, we have these parentheses. And my parentheses here, the parentheses for setup are empty because setup doesn't need to know anything extra to do its job. It knows that all its job is to run the instructions inside it when P5 tells it to. So they're empty. We will talk in the sequence of videos about putting things in these parentheses. So function, then setup. This bit's a little bit like a variable declaration, right? It's a similar idea. We use a special word to say we're going to define a function, which is the word function, just like we use the word let to say we're going to create a variable. And then we use, right away after that, the name of the function, just like we write the name of the variable after the word let. So it's a very similar idea. Okay, so function setup, then parentheses, they're empty, and then, like we've been seeing, we have curly brackets around some instructions. This is called a block of code. And inside these curly brackets is our definition of what the setup function should do. So the setup function will do all of the things that we write down inside its curly brackets. And in this instance, it's just the one instruction, create canvas 500, 500. And that is a function definition. We've got another one here as well. The draw function is another function that we are always defining in our programs. We know again that this is a special P5 program. P5 knows to call it because we call it specifically draw, spelled and capitalized in exactly this way. So again, we define it with the word function. We write its name, which is draw, empty parentheses because it doesn't need extra information to do its job, and then a block of code in curly brackets where we give it the steps, the instructions that it should carry out whenever draw gets called. We know that draw gets called 60 times per second. So that's a function definition. So we're already doing all of the stuff that you do with functions, which is to say we're calling them, like this ellipse function here. We call ellipse, and we're defining them, like this definition of the draw function. However, the real power of functions, generally speaking, comes in our ability to define our own functions and call them outside of just what P5 offers. P5 offers a lot, but it's very, very useful to be able to build up our own sets of functions that do specific tasks that we want to do in our program. And to discuss this, I'm going to write a program. I debated whether or not to have this kind of, here's something I prepared earlier, but I'll write this program very reasonably quickly just so we can get some more practice on thinking about this. So I'm going to write a program, a standard program where a circle begins on the left side, moves to the right side. It's going to reset back to the left side when it reaches the right side, and it's also going to, when it does that, it's going to get faster and bigger. Okay, so let's write that program. So first of all, of course, I'm going to need the ever-present circle object with the basic properties of a position, an x and a y. I'll make the y 250, so it's in the middle. A size, I love them to be 100 pixels, and it's going to need some velocities. I'm going to set its initial velocity to 1. I'm going to do a slightly less than perfect job here maybe, and its y velocity to 0. So its x velocity is 1, so it's going to move to the right. Its y velocity is 0, so it's going to move not at all in the vertical. In setup, I'll just create my canvas. In draw, I'm going to fill the background. That's good. I know that when I draw my ellipse now, I don't want to just draw it in the center. I want to draw it at circle X and circle Y. and I want to make it circle size. So that's good. But in between, I need to move the circle. The basic code for that we now know is that we add the velocity to the position, so circle x plus circle.vx, and even though it doesn't move in y at present, it makes sense to also include circle y is assigned circle y plus circle vy. That's just because we may do it in the future. And I'm going to fill my circle. I'm going to make it red just for a bit of a change. So now we should have a moving circle, right? We change its position in draw by adding its velocity, and then we draw it at that position. Because the position changes, the position of the circle changes. So we get a red circle, moves across the screen. Very exciting. I said that the other thing that I was going to do was that I was going to pay attention to when the circle reached the right-hand side, and I was going to move it back to the left. So I need to add an if statement here. If, and how do I express that the circle has gone off the right-hand side? Well, if the circle's x position is greater than the width, then it must have moved off the right-hand side, or at least reached it. And if that happens, I said I wanted to reset its position, so I need to put its x position back to 0. That will move it back to the left. And I said I wanted to do a couple of other things to make my program extra exciting. I said it would get faster. So I'm going to, in this instance, I'm just going to increase circle.vx by a set amount. It's going to get faster by 2 pixels per frame each time. So it begins at Vx of 1, but after the first time it reaches the other side, it's going to go up to 3, because I'm going to add 2 to it. Then it will go up to 5, and then it will go up to 7, and so forth. And I'm also going to make it bigger. So circle.size equals circle.size plus whatever, 5. So each time it reaches the right-hand side, it's going to reset back to the left-hand side, and the new incarnation of the circle is going to be faster and bigger. Just like we all hope our children will be every day or something. Okay, so now we should be able to witness that behavior. Off it goes. It's just about to reach the right-hand side. We're all excited. And there we go. It's picking up speed, and it's getting bigger each time. Bigger and faster and bigger and faster and bigger and faster and bigger and faster. And we'll see an example of what happens when this kind of process kind of runs away, because we're not constraining its size, so it can always get bigger, it can always get faster. And we get this kind of interesting visual effect as that happens, right? Where the circle's moving so many pixels per frame that it just sort of flickers, and then it kind of takes over the whole screen because it's just so big that it's everywhere on the canvas at the same time, which is kind of nice. The final thing that I want to do, and this is what's really going to get us into discussing functions, is I'm going to add a mouse pressed. And in the mouse pressed, I'm actually going to do the same things. I'm going to let the user of my program also reset the circle by clicking. So it's going to do the same stuff. It's going to set the x position to 0. It's going to set the vx to be vx plus 2. And it's going to set the size to be the size plus 5. So the same stuff, right? And that just means that it's a bit of interactivity. So when I click the mouse, those same 3 things are going to happen. So if we head back over, circle's doing its thing. Now if I click, it moves back to the left. Click, 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 click. And it happens when it moves off the right-hand side. So the same thing happens if I click as if the circle reaches the right-hand side, right? And as I've mentioned before, but now as becomes really, really apparent, repetition in programming is usually a sign that we can do something to improve our program, to make our program easier to read and more efficient in a sense. And we have some very serious repetition here, right? Inside my if statements block of code, inside its curly brackets, we've got these 3 instructions. Set circle x to 0, set the velocity of the circle to increase it by 2, and increase the size of the circle by 5. And then if we go and look in the block of code for our mouse pressed inside its curly brackets, we have the identical 3 instructions. That is 100% a sign that we need a function. Okay? So we have repeated code, and this repeated code should be inside a function so that we can use it more effectively. Let's do this. So we already know how to define a function. We've already talked about this. We need to write the word function. Now here, we need to write the name of the function, But now we're not defining a function that P5 already knows about, we're inventing a new function. So we can call it whatever we want. And I'm going to call it reset because, at least in some sense, what the code that we're wanting to deal with here, what it does is it resets the circle back to the left, as well as changing a couple of other properties. So we'll call it reset. It's like draw and mouse pressed. It doesn't, and setup, it doesn't need any extra information to reset our circle. So it's going to have empty parentheses. And then it needs to have its curly brackets to define the block of code that contains the instructions that are what reset does. Now, what does reset do? Well, it does the things that we've been doing here, right? The circle x, the settings circle x, circle.vx, and circle.size. So I could just copy those instructions. I just copied them with Command C, Control C on Windows. You should, if there's any keyboard shortcut that you should ever learn on a computer, it is the keyboard shortcuts for copy, which is Command C or Control C, cut, Command X or Control X, and paste, Command V or Control V. That will save you probably, like, I don't know, a year of time over the rest of your life. So you should do it. You could do other things with that time. So we've copied this code that gets repeated, and I'm just going to paste it inside the parentheses, inside the curly brackets for reset. So this is our definition of how reset works. If reset is called, and right now it's not, it's going to do the things inside the curly brackets, the block of code, and those are the things that we wanted to do both inside our if statement and inside our mouse pressed. So we've got a definition of a function that knows how to do those things. So the final step that's rather important is, rather than doing these three things explicitly here, instead we're going to call our reset function. And we call it just the same way we call any function. We write the name, then we write the parentheses after it. Again, reset doesn't need any information, so they're empty. And then we have our semicolon to say, we're done, thank you very much, or whatever. And this will call that reset function. So we've got the same situation, right? If the circle's x position is greater than the width, it's reached the right-hand side, call the reset function. That means do whatever the reset function has inside of its instructions. And we know that this would then kind of jump down here, because this is the reset function, and it would execute these three instructions here. That's what it would do. So by calling the reset function here, we're telling JavaScript to jump to the reset function here and do the instructions inside its curly brackets. And the effect is the same, right? It's as if those 3 lines of code were still here in this if statement, but we've just given them a name and we've moved them into a function. We can do exactly the same thing in mouse pressed. So we've got those same instructions, so instead of writing them out in full, we can instead just call our reset function and it will, again, do the same thing. So that's already kind of wonderful. One of the things that it gives us is it makes our program that much more legible, right? Now we know that what we mean is that when the circle reaches the right-hand side of the screen, we want to reset it. That wasn't immediately obvious by just reading the instructions, right? So we've given those instructions collected together a name, a meaning. They reset the circle. And we can also now very easily see that when the mouse is pressed, we also reset the circle. So our program has become significantly more readable. That's wonderful. That's a really good quality of functions. Even just that is a fantastic thing. Don't forget that the other great thing that it's doing is now we're only writing out these 3 lines of code once, because we define the function once, so we only need to say what the function does once, and then we call it in 2 different places, so we're getting some extra benefits there. And in fact, our program is shorter now because we called that function. Shorter is not always better, but in this instance, it's an improvement. The other very, very powerful thing that we now have is that if we want to change what resetting our circle means, if we want to add to it, for example, like change something else about resetting our circle, we can just change the function definition here, right? We can edit the reset function by adding something to it, and we will know, because we're changing its definition, that when it gets called here in this if statement, and when it gets called here inside the mouse pressed, it's going to take account of that. It's going to do whatever is in reset. So if we edit the reset, say by changing something that happens to the y, so let's make the y get smaller by a smallish amount, maybe. Let's make it get smaller by 0.25 each time and see what happens. So every time the circle moves to the right-hand side, it does all of the other stuff, but now we've added a line which says that the vy, that's velocity on the y-axis, should go down by 0.25, that will mean it will start to gradually be moving up as well as to the right. So it's going to start moving diagonally more and more each time it gets reset. And so let's save that and see what that looks like. So we head back. Circle begins, it's just moving purely horizontally, right, because the Vy starts at 0. But when it resets, it's starting to move diagonally up and to the right, more and more as it resets. And the same thing, if I click, same thing keeps happening until it kind of moves off the top of the screen, right? If I reload my program, I can cause that to happen by clicking. So I click, 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 and because it's calling that same reset function, we see the same behavior. This is a huge win, right? This ability to just now edit the reset function, it makes our program more efficient, it makes our lives easier, we don't have to make this line change in more than one place. And it just, again, it makes our program easier to understand. We understand what resetting means instead of just writing lines of code wherever we think we need them. So huge, huge wins by writing this reset function. This whole idea of making our program easier to understand with functions, it's not only something that applies when we are repeating code, right? So in this instance, we wrote our reset function in part because we saw that we had the same code in more than one place. And so the reset function was a way of making our program better and more efficient. And it had huge wins because of that. But we can actually also just use functions for that other benefit of kind of giving names to parts of our code to make our program easier to read. So let's have a look into our draw loop again and just look at the pieces of this draw loop. What does the pieces of this draw loop mean? Well, we set the background to black. That's kind of a universal thing that we often do in draw just to make sure that we have animation instead of just kind of shapes drawing themselves across the screen or smearing themselves. So that's pretty standard. That's just a single function call. But now we do start to have some things that mean something. So these two lines here mean that the circle moves, right? Those are the ones that change its position. So they move it. So that has a meaning. So why don't we turn that into a function as well? Let's do that. So let's cut those lines. That was Command X. And down below draw, let's define another function. And we'll call it move, because that's what we said that those two lines of code meant. And curly brackets to define what move does. And then I'm going to paste those two lines into move. So we've basically just moved, ironically, or like appropriately I should say, that's not irony whatsoever. We've moved the code from draw, where we had it written out in full, into a function definition called move, and we've just pasted them in there. So we've just relocated that code, right? In order for them to still apply in our draw, we need to call the move function, just like we did with reset. So now in draw we fill the background, then we call the move function, and what the move function does is what's inside its curly brackets. It changes the x and y position based on the velocity. So our draw has gotten easier to read, right? Now we know that it draws the background and then it moves the circle, because that's what the entire program is about. If we don't want to, we don't even need to know what move does. We can just take it on faith that something is being moved. If we do want to know what move does, because we want to change it or just know the details, then we can go down to our function definition and read the specifics. So we've got that same effect of not needing to know all the details unless we want to. So let's keep doing that. So here, well, what does this if statement do? This if statement checks if the circle is greater than the width, and if it is, then it resets the circle to the left. So we might call that wrapping the circle. We're wrapping it from the right side back to the left side. It's a term that you often hear in game programming especially. So let's move this into a function called map. Again, we can use cut, so Command X on my computer, and we can define a function called wrap. Exactly the same syntax again. Function first, then the name, empty parentheses because I'm not doing don't need extra information, and curly brackets to put my code in. I paste that code in, so now the if statement is inside my wrap function, and I need to call it after move, wrap. Write the name of the function, the parentheses, and a semicolon. So now again, draw comes, it fills the background with the p5 function, then it sees the move function, so it jumps down to here and does the things inside the move function, which repositions the circle, comes back up to here, and then it sees that the next thing it has to do is call the wrap function. So it jumps down to the wrap function and does the things inside that, which is to check first whether the circle has exceeded the width, and if it has, to reset the function, which is another function that we wrote. Finally, we've got these two lines in draw here. These display the circle, so we could move these into a function that we call display. I'll tell you a common thing that I do when I'm doing this kind of work of changing my code to be based on functions instead of just all being written in draw, for example. And this is something that we call refactoring when we reorder our program to be more organized. What I will often end up doing is I will cut these two instructions because I know that I want them later on, so Command X or Control X on Windows, and then I'll actually write the function call before I've even defined it. So I know that I'm going to call this function display. Display doesn't exist yet, I just know that I'm going to write it. So it's a safe thing for me to call it there, even though I haven't defined it. I wouldn't now go and check if my program works because I know that display is not defined. So I do then need to immediately go and define the display function in the same way that we have been and paste the code into its curly brackets. So function display, and that will set the fill and draw the ellipse to the screen. Now our draw function is truly a beautiful thing to look at. It sets the background to black, then it moves the circle, then it wraps the circle if need be, and then it displays the circle. That's a beautiful little story of what this program does with none of the visual clutter of all of the different pieces of code. This has made my draw function very readable, but all of these function definitions are also very readable because we know that this is a move function. We have a lot more context for understanding the kind of code that's in here. That also makes reading this code easier as well. Same thing for the wrap function. We know what to expect from this code, and the display function, same thing. Further, as we discussed before, we also know where to go if we want to change some of this code. If I'm looking at my program and I think, well, I really want to change what the circle looks like, maybe I want to change it to be a rectangle instead of a circle, I know that I would do that inside the display code. It's a bit stupid because my variable is called circle, but let's change it to a rectangle. And we know, and I'll set the rect mode to be center so that it behaves like the ellipse does, rect mode. We knew that we would just edit our display function. We didn't need to go searching through draw to find the right place. We've got it in a function, so we know exactly where we want to make those changes. So if I go and look at my program now, we have the same program except it's being displayed as a square, and it's got all of the same behaviors, but all of those behaviors are now being defined in functions instead of in just in the main draw loop. So I'm just going to undo back to the ellipse because that's a bit more sensible. So what we have there is a gorgeous, gorgeous program, I think. I think that it's important, ideally, to take pleasure in how nicely organized this code is. Both because the draw loop is very simple now, that makes the draw loop easier to read and to make changes to, and because we have all of these nicely named and defined functions that separate our code into meaningful units that we can work with more easily. So defining functions is super useful, both because it just organizes our code into different sets of instructions with names. And what we call that, by the way, in the world of programming is modularity. Each of these functions is a little module of code that has a specific meaning. This is the move code, this is the wrap code, this is the display code, etc. So it's modular. We call that modularity. And the other great thing that we saw was this reset function. We use the reset function twice in our code, but we only need to write the code once, and that is called reusability. The reset function is reusable. We can call it in more than one place and gain the benefits of that function in more than one place. Just like we use the ellipse function in lots of different places, say, as well, if we're drawing multiple ellipses. So modularity and reuse, two of the pinnacles of good programming, are something that we start to unlock with functions. I'll see you in the next video, and we'll talk much more about defining our own functions and making them even more powerful. Bye for now. Stop recording.